Welcome viewers. In this video, you'll see the various parameters of the series resonance. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. We'll see the parameters in series resonance. That is selectivity, quality factor, half hour frequencies, bandwidth. These are all the parameters we'll see. The series resonance, the explanation available in separate video. So first we will see the graph, the current versus frequency curve of a RLC circuit is symmetrical about the resonant frequency. So here the curve available, x-axis frequency, y-axis current. The graph is drawn between frequency and current. So when the frequency increases, the current also keep on increases and reaches the maximum value at this point, thereafter decreases. So this corresponding the maximum value is known as I equal to E by R. The corresponding frequency is F naught. Then we have one more current is there, half hour current and half hour frequency. So the line is drawn here. These are all the 2 points, point 1, point 2. The current is I1 equal to I2. At point 1, the corresponding frequency is F1. This is called lower half hour frequency. At the point 2, there's a line is drawn. At that, the frequency is F2. This is upper half hour frequency, right? So the graph is drawn between frequency and current. The maximum point, the corresponding frequency is F0. At half hour, the frequency is F1, F2. Half hour, this is the lower half hour, this is upper half hour, right? Now we'll see the further detail. Now we'll see what is the value of F1, F2, F0, what is I1, I2. These details we will see one by one. So at frequency F0, the current is maximum and is given by E by R. There will be two frequencies, F1 and F2, on either side of the resonant frequency, at which the power is half the power at resonance. So they are all called a half hour frequencies. In that, F1 is the lower half hour frequency, F2 is the upper half hour frequency, right? So the current is maximum at the resonant frequency F0. That current is given by E by R. On either side, we have two more frequency, F1 and F2. This is called half hour frequency. F1 is lower half, F2 is upper half, right? Now we'll see the power at point 1 and 2 is I1 square R equal to I2 square R. So power at resonant equal to I2 square R. By definition, half hour frequencies I1 square R equal to I2 square R equal to half I square R. This is half hour. Because of half hour, it is 1 by 2 I square R. Now we'll go for further details. So I1 equal to I2 equal to 1 divided by root 2. So that is 0.707 I. We will take this equation number 1. That is, at half hour frequency, at half hour point 1 and 2, the current is 70.7% of the current at the resonance. So that is the important conclusion. At half hour, the current is about 70.7% based on this expression I divided by root 2. Let Z be the impedance at the half hour point, so that I1, magnitude of I1 equal to magnitude of I2 equal to magnitude of E divided by magnitude of Z. Take this equation number 2. I1 equal to I2 equal to 1 divided by root 2 I, that is equal to 1 divided by root 2. I is replaced by E by R. I equal to E by R. Take equation number 3. So from equation 2 and 3, both are same. So E by Z equal to 1 divided by root 2 E by R, right? Now we'll go for the further simplification. So equation 2, 3 is equated so that we got E by R, E by Z equal to 1 by root 2 E by R, right? Now this E got cancelled, so Z equal to root 2 R. So Z by R equal to root 2, by inverse, taking inverse, R by Z equal to 1 by root 2, R by Z, right? We know that cos pi equal to r by z. So r by z value available here 1 by root 2, that is 0.707. So the power factor is also 0.707, right? So that is what is the conclusion we got, that is at half power point the power factor is 0.707 or it is 45 degree. Pi equal to cos inverse 0.707 if you take, you will get pi equal to 45 degree. At F1 power factor is leading in nature, at F2 power factor is lagging in nature. So power factor is about 0.707, angle 45. At F1 it is leading and at F2 it is lagging, right? Now we'll go for the further analysis. So the impedance Z equal to root 2 into R. Just we got that value, Z by R equal to root 2. So take the square on both the sides. So Z square equal to root 2 is 2 R square. Z square equal to 2 R square. But we know that Z is impedance equal to square root of R square plus XL minus XC the whole square. For RLC circuit, this is the impedance. Now we'll equate these two, so that square root of R square plus XL minus XC the whole square, is, we are making the square here, equal to 2R square, because here Z square is there, here Z is there. The square is, we will take the square here. So while taking square, this square root will disappear. So R square plus XL minus XC the whole square equal to 2R square. Now bring this R square that side. So 2R square minus R square is R square. Now take the square root on both the sides. So XL minus XC equal to R, right? So XL minus XC equal to R, we got this expression. I will see what is the conclusion in that. So at half power frequency, the reactance is numerically equal to the resistance. So the inductive reactance minus capacitive reactance equal to resistance. That is the conclusion we got. XL minus XC equal to R, right? Now we'll take the frequency F1, lower half power frequency. XL minus XC equal to minus R. Because of lower it is minus R. XL is omega 1 L. We'll take at F1 the omega is omega 1. Minus 1 divided by omega 1 C equal to minus R. We'll take omega 1 C common, LCM. So it is multiplied here, a term not available, multiplied. Omega 1 L into omega 1 C minus 1 divided by omega 1 C equal to minus R. I will go for the further simplification. So by cross multiplying we got omega 1 square LC minus 1 equal to minus R omega 1 C. Now bring this term this side. So that omega 1 square LC plus omega 1 RC minus 1 equal to 0. So this is nothing but a quadratic equation. We will take the standard quadratic equation, ax square plus bx plus c equal to 0. Here x is nothing but W1, a is nothing but LC, b is RC, c is 1, c is minus 1. The c equal to minus 1, c equal to minus 1, not plus 1, c equal to minus 1. Now how to find the root? The standard formula available. Minus b plus or minus square root of b square minus 4ac divided by 2a. Now we can substitute all the value. B is RC minus b value is RC plus or minus b square RC square minus 4 into a. A is LC, c is minus 1 divided by 2a. A is LC, 2 into LC. Right. Now we'll split the terms. Now we are going to split the terms. So minus RC divided by 2LC plus, so we'll take only the positive, plus square root of R square C square, this R square C square. Well, this term while going to the inside of the root, it becomes square. 4L square C square. This minus and minus become plus. 4LC divided by 4L square C square. 2LC while going inside the square root, it become, we need to take the square. So that 2LC become 4L square C square. Right. Now we'll go for the further simplification. CC got cancelled. Minus R by 2L plus, here also C square got cancelled. So R divided by 2L the whole square can be written as R divided by 2L. Here 1C and here 1L got cancelled. So 4 also got cancelled. 1 divided by LC. So we will take this equation number 1. So at F1 we got this value. Now neglect this R divided by 2L square compared to L by C. Compared to 1 divided by L by C, this value is very lesser. So that we can neglect this term. So after neglecting this term, what happened? Minus R by 2L plus or minus square root of 1 divided by LC. Right. We'll take this 1 divided by LC is omega naught. We know that 1 divided by square root of LC is omega naught, the resonant frequency. So omega 1 equal to R divided by 2L plus 1 divided by omega square root of LC. Right. So omega naught can be written like this. Both again it is omega naught is replaced. Now the frequency, lower half frequency F1 equal to omega 1 divided by 2 pi. That is omega 1 equal to F1 into 2 pi. So that F1 equal to omega 1 divided by 2 pi. Now substitute this omega 1 value. So minus R by 2L, minus R by 2L plus 1 divided by root pi 2 pi into root LC. This 2 pi is available in the denominator, right? Already 2L is there, into 2 pi is 4 pi L. Here also 2 pi, right? Now it is F1 equal to F naught. We'll take this value as F naught, the resonant frequency at the frequency at the resonant, F naught minus R by 4 pi L, right? The F naught equal to 1 divided by 2 pi root of square root of LC, right? So we got the lower half frequency F1 equal to F naught minus R divided by 4 pi L, right? Now similarly we'll go for the frequency F2, second frequency, upper half frequency F2. At F2 XL minus XC equal to R. Earlier it is minus R. Because of upper half it is plus R. XL is omega 2L. In F1 we take omega 1. In F2 we are taking omega 2. Minus 1 divided by omega 2 C equal to R. Take the LCM so that this term is multiplied. So what will happen? You multiply this omega 2 square LC minus 1 divided by omega 2C equal to R. Now we'll cross multiply this. Then we'll go for further simplification. So we'll cross multiplied omega square LC minus 1 equal to omega 2 CR. Bring this term this side. So it become minus omega square LC minus omega, this omega 2 square. This is omega 2 square. This is also omega 2 square. Minus omega 2 CR minus 1 equal to 0. So this is nothing but a quadratic equation. The standard quadratic equation is ax square plus bx plus c equal to 0. Here x is nothing but omega 2. A is LC, B is CR, minus CR, and C is minus 1. Now we can substitute the value minus B plus or minus B square minus 4AC divided by 2A. So minus B is minus CR plus or minus square root of minus CR square minus 4 into LC into minus 1 divided by 2A. A is LC, right? Now this minus minus become plus CR plus or minus CR the whole square is CR square, right? This minus become plus C square R square. Then here negative is there, both the negative become positive, 4LC divided by 2LC, right? Now we'll split the terms. Now the terms are splitted together. So while splitting, what happened? CR divided by 2LC plus or minus C square R square. So while going inside, 2LC while going inside, it become 4L square C square. We need to square this term. Plus 4LC divided by 4L square C square. So CC got cancelled. R divided by 2L. Plus we will take only the positive. So here the C square got cancelled. R square divided by 4L square. Plus here 4 got cancelled. L one term got cancelled. 1 divided by LC. Right. So we'll take this R divided by 2L plus R divided by 2L the whole square. We'll take whole square plus 1 by LC. Now we can neglect the term. This R divided by LC we can neglect. Compared to this term is very lesser. So after neglecting, what we got? is omega 2 equal to r divided by 2l plus or minus 1 divided square root of 1 divided by LC. Right? Just this time we know that this is nothing but omega naught. Right? So F2 equal to omega 2 divided by 2 pi. So this is the angular frequency, this is the frequency, upper half frequency. So the omega 2 will substitute here. R divided by 2L into 2 pi is 4 pi L plus omega by 2 pi. Right? So we'll take this term. Omega by 2 pi is the F naught. This omega by 2 pi can be taken as a F naught. So that what we have, F2 equal to F naught plus R by 4 pi L. Earlier we got F1 equal to F naught minus R by 4 pi L. Now we got plus 4 plus R by 4 pi L. So now we got the lower half frequency as well as upper half frequency. Now we'll go for the next parameter. So next we will find the bandwidth. Bandwidth is F2 minus F1. We got the expression for F2 as well as F1. F2 is nothing but F0 plus R by 4 pi L minus of F1 is F0 minus R by 4 pi L. Now we'll multiply this negative inside. So minus F0, this minus minus become plus R by 4 pi L. So the F0 got cancelled. R by 4 pi L available 2 times. 2 times of R by 4 pi L. 2 here the 4 here 2 times gone. So it is R divided by 2 pi L. So the bandwidth F2 minus F1 equal to R divided by 2 pi L. So we got the expression for bandwidth also. Take this equation number 5. Now we'll go to the quality factor of a series resonance. What is the quality factor? The ratio of F0 to F2 minus F1 is called the quality factor of a coil. That is Q equal to F0 divided by F2 minus F1. So F0 divided by this F2 minus F1 is R divided by 2 pi L. Just now we calculated. This 2 pi L will go to the numerator. So 2 pi L F0 divided by L. Right. This 2 pi F0 can be written as omega naught. So that omega naught into L by R. Omega naught L divided by R. So Q equal to omega naught L by R. Right. So also it is written as Q equal to 1 divided by omega naught CR. This is in terms of inductance. This is in terms of the capacitance. Right. So from equation 1 and 3, we already have the two equations, omega 1, omega 2. From that we can go for one more expression. Omega 1 into omega 2. This is omega 1. This is omega 2. What is the difference? Minus R by 2L. Here plus R by 2L. So this is nothing but A minus B. This is A plus B. This time is A. This time is B. A plus B into A minus B. That is nothing but A square minus B square. Right? So this A square, will take this A square. While taking square, the square root disappear. R divided by 2L the whole square plus 1 by LC minus B square. This R by 2L is the B. So R by 2L the whole square. Right? A plus B into A minus B is nothing but A square minus B square. Right? So these two terms got cancelled. So what we have, omega 1, omega 2 equal to 1 divided by LC. But omega naught square is 1 divided by LC. So omega naught square. So omega 1 equal to omega 2 equal to omega naught square. The resonant frequency omega naught square equal to resonant frequency at lower half into upper half. So based on that we write the frequency F1, F2 equal to F naught square. Right. Now we will see the quality factor. Q equal to omega naught L by R. That is equal to omega naught is 1 divided by square root of LC into L by R. Right. Now how will you write this? This square root of LC is written separately. 1 divided by square root of L, 1 divided by square root of C. This L is written as square root of L, square root of L. So square root of L into square root of L is this L. So in order to simplify, it is written. So this L got cancelled. So what we have, square root of L divided by square root of C into R. So that can be written as 1 by R into square root of L by C. So the quality factor, one more formula is 1 by R square root of L by C. So in this video, we will see the various parameters of the series resonant. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.